Hello everyone, welcome to our next podcast, the IEEE ComSoc podcast number 15. So today we are here with two of my colleagues, Dr. Mona Jaber from Queen Mary, University of London in the UK, and also Dr. Antonino from Queen Mary as well. So I'm having a hard time to pronounce your name, so maybe we'll keep to
Antonino Masaracchia. Thank you.
Yeah, thank you. So basically here we are to discuss about several sort of aspects of 6G and what can be actually utilized as, in terms of the latest solutions and updates and so on. So in particular, we're going to talk about digital twin and ORAN, and also something about machine learning and sustainability aspects that are related to 6G and beyond. So this is basically the topic of sort of conversation that we will have today with this podcast. So first of all, welcome Mona and Antonino.
Thank you.
Thank you very much for having us today.
Yeah, thanks for being here. I think it's so nice to have you guys here. We don't have a good weather outside, but we try. That's why we stay indoors.
It's London. It's always the case. And it's February in London, so that's what you expect.
Exactly. So let me start with something quick, with some sort of basic stuff at first. So maybe I can pose this to you, Antonino, about like ORAN. So since you have been working on this technology and several other along with that. So I wanted to ask the fundamentals of ORAN. So what do you think about this technology in general and the basics behind this? Like what are these sort of definitions and some fundamentals around this technology? And then we will later pick on like the benefits and so on, and then we will continue our discussion further. So Antonino, if you would like to start, talking something about ORAN.
Okay.
So ORAN is Open Radio Access Network.
Yes, exactly. You're right.
Please go ahead.
So yes, the concept of ORAN is quite new. I mean, let's say the ORAN Alliance was established in 2018 with the main concept of revolutionizing the radio access network. This why? Because we are expecting a collapse of the 5G. But the point why is the traffic is increasing and the number of devices will going to increase as well. So the 6G networks are expected to serve up to 10 million of users per kilometer square. So the point is that the upper layers of the network, like the IP layer, the application layer, the data link layer, they are very well optimized at the moment. So we in line with this trend, it is expecting that the radio access network will going to collapse soon, and that there will going to be a lot of work on doing on that. So this is why the ORAN Alliance, together with the other alliances, has been established to revolutionize the radio access network. In which way? By embedding the concept of openness and intelligence. Openness, why? Because the radio access network so far account for the 70% of the capital expenditure for a mobile network operator. So the mobile network operators are in pressure to update their network. So they are looking, of course, for cost-effective solution, a very more flexible solution. So embedding the concept of openness, this will gonna give the possibility for other providers, infrastructure providers, to go into the market, because so far there are just few infrastructure providers and all the software are locked in, and most of the time they are not interoperable to each other. So inducing and putting the openness, we're going to open the market to other possible infrastructure vendors, and the interoperability, which we're gonna help the mobile network operators to combine and build the best of breed radio access network for the network itself. So this will the introduction, of course, of new players into the market will going to reduce the cost, because there will going to be competitivity. So there will going to be more competitive market.
Right.
So as regards the fact of the intelligence on the top of the radio access network will going to allow the possibility of providing real-time decision making and informed, because there will going to be the possibility through the open radio access network to collect the data, because not only the software but also the main interfaces of the network itself will going to be open, so it will going to be possible to collect data, and through the application of AI and machine learning will going to be possible to elaborate this data and find new partners that will going to help to give to the mobile network operators informed decision for real-time optimization, and then provide the main of the key performance indicator of 6G, which are going to be ultra reliability requirements, low latency communication, which meaning latency less than 1 millisecond, hopefully, and higher communication speed, which is expected to be around 1 gigabit per second in downlink. So that's it. This is the main concept of O-RAN. So intelligence and openness, we're going to revolutionize the next generation of radio access network, and it's expected that this will going to foster the possibility of deploying 6G use cases like augmented reality, virtual reality, tactile internet, and autonomous driving.
Yeah, I think this makes sense. I think when we mentioned about the point of URLLC sort of use case as well, let's say. So basically NTN also relates very well with us. So when you talk about the non-terrestrial networks and integration with terrestrial network, of course we'll touch on that later in the podcast. I mean, so the thing is that it does look like that there might be some complexity issues involved, right? So when you mentioned about, let's say, implementing O-RAN for like networks and stuff like that, for 6G and beyond networks we're talking about. So there will be some sort of complexity bottlenecks, some cost inefficiencies involved. So what do you think about that? How we can actually get rid of these? I mean, are there any solutions we are thinking already, or something that might come up, let's say, in future that you're expecting in few years down the line?
So I think that for the managing the complexity of the network and taking into account all the variables that are involved in the network, I think that the concept of digital twin itself will gonna help to optimize the network itself. Because what is, let's say, in my opinion, the main problem of O-RAN? The main problem is that, no problem, I don't want to say problem, but the main drawback is that on top of this architecture there will going to be the real-time controller. But the software on the real-time controller needs to be tested before to be applied, and needs to adapt itself with the variability of the network itself, because the 6G will going to have a lot of use cases, a lot of variables compared to the current 4G, 5G. So with the concept of digital twin, there will be the possibility to replicate virtually all the network in a server in a distributed or centralized way. This will gonna depend on the mobile network operators, and which means replicate physically all the parameters of the network and also the software. So this meaning that the software, which means the XApps for the radio intelligence controller, can be replicated into the digital twin. Take the data, train it, adapt it, and then feedback to the radio intelligence controller in order that this will gonna be constantly updated and in line with the possibility of deal with possible scenario that will gonna happen with the variability of the network.
Yeah, interesting. So Mona, do you agree with him? I mean, digital twin correlating with
absolutely,
with O-RAN?
absolutely. And I think we always talk about digital twins as if it's a new concept. In reality, this is what we've been doing since GSM days. We had a simulation tool, and this is where we tested things before we actually deploy them. Now with Open RAN and with 6G, there's much more complexity in the network than what we had before. But operators would still want to validate whatever optimization algorithm, especially when it's delegated to machine learning and artificial intelligence. They will not trust a black box to run their network. They want to see how it looks like in a realistic network. And digital twins today are a realistic replica of the actual network. They replicate our network if we are the network operators, but they also replicate the traffic demand. So all these, for example, the IoT devices, be it in intelligent transportation systems, be it in manufacturing, be it in smart cities, the people movement, the kind of usage, all these new applications that we're going to have in 6G, we can model that in a digital twin. And that means that the results of the optimization that we're running with machine learning are realistic and are very similar to what would happen in the real network. And that would give operators the confidence to deploy that XApp, for example, in the real network. We're not there yet. It's a very long process. And with what we have today, with the computational complexity that we have today, we can do a lot. But there are still bottlenecks. And one of the things we've been looking at, for example, is how much gain is there to be had. One of the applications is
gain in terms of
gains. One of the things is looking at energy efficiency. So if I want to make my Open RAN more energy efficient, with these off-the-shelf boxes or processors that you use.
Yeah.
Of course, when you tweak the parameters, you can do that. Tweak the transmit power, tweak the antenna direction or the MIMO or so on and so forth. You can do a lot with the energy efficiency. How much does it cost to obtain that energy gain? If I'm using AI to do it, and AI is super costly in terms of computation, what is the actual balance? And this is something that the digital twin will allow you to model realistically the full pipeline, as opposed to just modeling a channel perfectly.
Yeah.
As we used to
So
do.
first, perhaps you even check on your digital twin model, like how it looks like, the performance gains, and in terms of energy efficiency, complexity, latency, or whatever is the KPI that we are sort of aiming, and then we might implement that in the real network as well later on. So maybe that assists us to sort of figure out things firsthand.
Yeah, and to test these things under extreme scenarios.
Yeah.
Right. So what happens when there's 2 times more traffic than expected.
Yeah.
Traffic demand, or more of this type of traffic with very low latency, traffic with high resilience. What happens? How would the network deal with it? And that's something that you can test on a digital twin easily.
Yeah.
And as long as you know that you can trust the results, then that would be very helpful.
So especially in the cases of, let's say, disaster management that we have to do, right?
Yeah.
Like there's like a traffic, like lots of traffic that is coming because all the infrastructure has gone down. So in those scenarios, maybe it's very useful to have like digital twin models at first.
Absolutely. Maybe you have some of the antennas are no longer working for one reason or another, because there's a tornado, because there's whatever. So how would the rest of the network deal with it? And these kind of extreme scenarios you can model. And that's very useful with the digital twin, for sure.
Yeah, correct. So what kind of like use cases we can think? So we were already talking about this public safety or disaster management scenario. So what kind of other use cases or applications we can come up with, guys, like when it's about ORAN and digital twin, or just ORAN or just digital twin? So how we can actually utilize these technologies for different use cases, as long as it's concerned, let's say, with 6G and even beyond, perhaps.
Of course,
Yeah.
Yeah, I mean,
thoughts on that?
One of the use cases, though, is just the part that I'm working most is related to the radio frequencies, so related to the channel estimation. So with the 6G, what's going to happen that we're going to have higher frequency, a lot of devices, a lot of interferences. So in order to guarantee the sub-millisecond latency for some application, it's very important to have a very accurate channel estimation of the communication. In particular, also if you are also dealing with the reflective intelligence surfaces, which is also another technology that we're going to be embedded in the future, or the concept of movable antenna. So if you have the possibility of good channel estimation, this will going to help to improve the communication performances. So with the digital twin and the ORAN, what you can do is just collecting the data, the measurement, putting in a background in the digital twin engine, and using AI tools or deep learning, or for example the long short-term memory cells network. For example, you can create an entire map of the channel condition at the moment and do prediction in order that for the next time slot, or taking also into account the mobility of the users, you already have in place the solution to guarantee that kind of delay or that kind of the reliability for the communication. And this can be very important in the context of autonomous driving.
Yeah.
Because if you don't have a good communication in autonomous driving, this can gonna cause very serious damages and problems.
Exactly. Especially with this driverless cars coming in, and and like we're approaching, in China, I've seen that they are doing these driverless cars, and perhaps it's best to make it all automated, but with some intelligence in the backbone.
You have to have intelligence, and you have to have the low latency. I mean, we looked at one specific issue with autonomous driving, for example, is assume that you have all the sensors in the car and you want to predict if a pedestrian is going to cross the street.
Yeah.
To make sure that that car doesn't hit the pedestrian, right? You want the information to be processed very fast, but you want the information to be transmitted very fast.
Yeah.
Because a car on its own doesn't have it doesn't have the 360 visibility all the time. So you want to have this collaboration, the V2V or the V2X, the vehicle to everything.
Or V2I sort of stuff, yeah.
Exactly.
With almost everything, yeah.
Exactly. But you want that latency to be super low.
Yeah.
And you want the complexity of the algorithm that is analyzing the sensor data to be also low for it to run on our infrastructure. So this is a very big challenge. And you can solve each bit of that complex problem very well, but put them all together and measure the actual latency from the time the pedestrian intends to cross to the time the vehicle has reached that decision. It needs to be really very, very, very low, within the 1 millisecond that we're talking about.
Yeah.
How
exactly.
do you do that?
So I think these kind of solutions that we're talking about, perhaps they are going to be implemented for different sort of applications and use cases.
Yeah.
So I think in addition to sort of autonomous driving, I can think of, again, non-terrestrial networks. So basically you have to integrate your ground network, your sort of terrestrial sort of nodes with non-terrestrial entities. So it can be drones or your satellites or stuff, right? So you require very low latency sort of solutions. Yeah. Otherwise, there's no point of implementing like non-terrestrial network-based sort of connectivity, because that's the point, right? That you have the highest reliability possible, as less interference as possible in multicast or multi-user scenarios, and low latency as well, which is basically one of the objectives that we are dealing with in 6G. So that one, and also when you mentioned, Antonino, about like channel estimation, channel modeling. So I think about also sensing and communication when you join them together. So this might be very useful, that how you actually model your channel. Exactly. Or estimate your channel first, because the channel characteristics are quite different for sensing and communication, right? Because the sort of propagation properties are different, and you might be sort of also dealing with sort of this dual function signaling that you're trying to sort of achieve with this joint operation. It becomes quite complex if you don't have the correct information about the channel itself to pass on this information. So I do think that, I mean, you can link several sort of technologies together. Yeah. So let's say ORAN or digital twin sort of techniques, you can use it for multiple other approaches as well, and kind of have multifold sort of benefits sort of out of these approaches. That's very well. So what do you guys think about sort of, let's say, the future prospects of these technologies? So going further, so we do see there are use cases, autonomous driving, public safety, combining with other technologies which are important for sort of 6G framework that we have. So like going forward from here, so what do you guys think, that what's latest, let's say, digital twin, and what kind of future prospects you are thinking that will be brought forward in next couple of years, let's say?
So, of course, as Mona was saying before, this is a scenario that needs time to be developed, in particular for the digital twin. So there are still some challenges that needs to be addressed, and the research community, both research and the industry, they are putting a lot of effort to solve these challenges. The main important thing, as we said before, is that we will gonna have the digital replica of the system, but at the same time we have to guarantee a very good representation of the system. So this meaning that we have to deal with the possibility of missing data for the representation of the digital twin, and latency on receiving data from the physical layer. Because if we do not have a real virtualization, a virtual representation of the system, this can compromise the decision making from the decision policy that the digital twin will gonna give to us. At the moment, the most it has been, just from some of my colleagues, has been shown that one possible approach to overcome this is just providing a distributed approach. It's been shown that giving a distributed approach for the digital twin can improve the accuracy, as well as the possibility of having edge server very close and store particular data that will gonna be helpful for the forecast of the data itself. So this will gonna be one challenge. Another challenge will gonna be the fact that we're gonna have a lot of data to deal with So even the digital twin will gonna have a lot of data that needs to be annotated
Yeah.
for training purposes and needs to be analyzed. So there will gonna be the need to develop very autonomous data annotation, because so far the data annotation is doing manually. But in the
Yeah.
future, we cannot expect to do this manually.
I mean, we're trying to plug in some sort of AI algorithms, some efficient
Yeah.
algorithms at the back end to basically, train the model in a ways that you may not have exactly the same sort of, let's say, representation of the realistic model that you're trying to achieve using digital twin. But you might train your data in a ways that you are at least very highly accurate as possible, right? But that requires, as you were also saying, Mona, a lot of complexity, because your servers or your programmers that are going to be in, like, algorithms or whatever is going to be very complex. And with the digital twin data, I mean, even if you model it, even if you predict that what can be the next best output, let's say, right? You keep training your model. That is quite complex as well. So all in all, the data is huge.
Absolutely,
right?
Yeah.
Absolutely.
So this makes things even more complex in a way. So how we can actually get rid of, let's say, these complexity issues in certain ways?
I personally don't think we can get rid of it, but we can play with the diversity of demand. So you said as accurate as possible.
Yeah.
Perhaps it's not always needed that it's as accurate as possible, as accurate as needed. And some things need to be more accurate than others. There are some things where we can work with the margin, because we know that in any case that signal level is changing so fast for various reasons, with reflected surfaces, with so many things.
Yeah.
So we don't really need it to be 100% accurate. We want it to be...
I mean, it will never be 100% accurate.
But it shouldn't
But
even be the target. So it's about optimizing the utility of the model and the complexity of the model jointly, as opposed to doing these two things separately. So how can I achieve what I need by consuming the minimum complexity? That is the new problem that we need to solve, as opposed to how can I find the best AI model that gives me the highest accuracy. It should be which one would give me the best utility.
Yeah.
Looking at both of these together.
Yeah, I think that's a very good point. I mean, when I actually talk to some partners and sort of stakeholders, I mean, their vision has been that the models that you approach, of course, they have to be as low, in complexity as possible, and also they want to achieve actually higher accuracy for their models. In a way, it's because that's basically deciding the sort of sellability of the product that they're trying to achieve, right? And when it comes to 6G sort of like use case and application, that 6G is very use case and application based. I mean, we are very ambitious already with the objectives that we have decided. So people are trying to push the boundaries in a way.
Sure.
So when I was meaning like the highest accuracy, I mean, people are actually trying to
absolutely
work around these and trying to push the limits as much as we can. But this depends on, again, I agree with you as well, that this depends on the sort of scenario that you want to achieve.
Yeah.
Somewhere you may not have the aim of just accuracy. Maybe you need to look for some other aspects as well.
I mean, I think what Antonino said earlier, when you introduced ORAN, the main purpose is to have this radio access network open for different vendors,
right?
And to bring the cost down.
Yeah.
You want to bring the cost down, and this is the flexibility that ORAN gives you in terms of reconnecting different vendors together to offer the RAN. This is where the cost gain is coming from. You don't want to go against that trend and make everything very computationally expensive. That will bring the cost
That is
up
also
again.
something we need to keep in mind.
So that I think that this is one part that I wanted to say. There was another thing that I wanted to talk about, again, about digital twins, and it's the evolution of those. So I think where we are today, the most realistic digital twin that we're able to implement, not for the whole network, for part of the network, would be data streaming all the time with automated labeling. Could be using generative AI to label the data, could be using different other algorithms.
Interesting.
And models that are being updated with the incoming data, and intelligent decisions being made. But the feedback from the virtual world to the physical world is still done by people. And we haven't automated that. because we haven't reached that level of confidence, that level of maturity. And the ultimate goal of a digital twin, together with ORAN, where would it be in the future? I think it would be that. It would be completely automated, without a man in the middle, for the feedback from the virtual world to the physical world. And there will always be that correspondence between both, to always be up to date and to always know what data to throw away. You don't want to keep all the data. So when you have
some redundancy as well in the,
yes.
in the data, exactly.
That takes a lot. It takes a lot of maturity before we get to that point.
Do you think this will be feasible during 6G, or we are looking somewhere beyond, like 6G Advanced or something? Because this sounds interesting to me quite a bit.
Yeah, I think that it might be an enabler to 6G, because when you have that very tight coordination between the physical world and the virtual world, you can really enable the most flexibility in the network. You really optimize these resources where they are needed all the time, continuously. And this is the most cost-effective network, if you wish, right? But I think it is important. We're going to get to that, and it's not a jump from where we are to that. It's going to be small steps. We always go in small steps until they mature, and then we move to the next step.
Perhaps different communities need to come together, like experts in LLMs and Gen AI and stuff have to come together to
absolutely.
With the sort of physical layer guys and stuff like that.
Yeah.
I think that for the autonomous part, we have to reach the point in which we trust the machines enough for the decision.
It's a big issue again, trustworthiness with AI. It's quite huge.
Yeah, that's it.
I mean, there's like a lot of data coming in from almost everywhere, and how do you actually handle that and actually trust it or not to predict the right outputs or not?
Yeah, but also for this, just there are some other possibility for reduce the amount of data. One can be, for example, for analyzing the data, quantum computing is showing a very interesting result on achieving good results in less data compared to traditional AI algorithm based. And another thing to reduce can be also the usage of semantic communication. Instead of transmitting the whole messages, we're going to transmit the meaning behind the message, and this will going to reduce the data, and potentially we're going to help to automate the entire process because we have the meaning behind and all the whole message. So that's it.
Absolutely. It's got to be a lot of, I think you talked about distributed computing, and this is an essential component of a digital twin. You have to have that intelligence at the edge. The first task is to get rid of the data that you don't need. A lot of the data is garbage. Yeah,
you can use maybe like edge cloud computing solutions, basically. So, I mean, for example, in non-trusted network scenario, you want to deal with like inter-satellite links, right? So you can put them on your edge plane, all the communication that is happening there. And some information that is computationally inefficient, you might put it in your cloud, let's say, right? So you might not require it right away, but it's stored in a cloud somewhere. And then you can make this kind of like tier network architecture, maybe like inter-satellite links on your edge plane, some other information on cloud, and then you're also dealing with, let's say, your marine areas, IoT areas, disaster sort of affected areas, and so on.
And I think with Open RAN, please correct me if I'm wrong, it even gives you more flexibility within the RAN. So where do you want to instantiate the different modules of the Open RAN? At the edge or somewhere, the remote unit and the distributed unit and the central unit. Where do you want to have that? And that can be, again, dynamically designed and optimized to meet the requirements of the use case and of the application.
I completely agree with
you. But it becomes very complex, guys, in terms of vehicular scenarios when you were mentioning about the automated vehicles and V2X, V2I you were mentioning. Because these are moving sort of vehicles, right? So the mobility is like high mobility scenario. I mean, of course, we are gaining some other benefits, but it's quite complex, again, when it comes to like the moving vehicles and sort of maybe even flying platforms like in non-trusted network scenarios, for example. So how do you actually enable edge cloud computing or this sort of intelligence we're talking about with ORAN? So this becomes quite complex again with moving with the high mobility scenarios. Right? Yeah.
Yes. I will say that we have the basis for the development, but now we need a lot of research on these topics.
Yeah, it seems like we need to do a lot yet.
Yeah.
We do, but this is the exciting part,
Yes,
right?
exactly.
I mean, this is what we love doing. We love having a problem to solve
Exactly.
and, you know, coming up with the tools to do
So
it.
are there any projects that you guys are working on that you want to highlight during this podcast? Something that you're working around?
I mean, I could talk about perhaps a couple of projects.
Mhm.
One of them is about the digital twinning of a mobile network.
Right.
The tool we're working on is based on 5G, but it doesn't mean that it can't be updated to reflect 6G. And it's a digital twin which is designed with complexity in mind.
Yeah.
In a sense that the code is written to be as low complex as possible, to be as efficient as possible in terms of computation, and it is designed to allow for Open RAN and for machine learning algorithms. So, for example, one of the applications we're trying with that digital twin, we didn't create the twin. It's a collaborative project, and we're looking at how do we optimize the energy efficiency. Again, energy efficiency is one of the things that we've been talking about since GSM days.
Yeah. I think this was the biggest issue, Mona, during 5G implementation, actually, that we were like just aiming mostly for the sort of high data rates and achieving the highest capacity possible, but we were not really too much focused, let's say, on the green aspects, which we are trying now in 5G Advanced and 6G to also make things efficient. Yeah.
True, absolutely. And I think it's a bit of a trade-off, right? And I mean, if you read the most recent papers, the solution for energy efficiency is use this very fancy AI algorithm, and it's going to give you the energy efficiency, the optimum solution.
But there is a trade-off.
That's great. But
Yes.
I mean, AI is very complex. I mean, you know, LLMs, like large language models, produce more CO2 than 5 cars during their lifetimes, right? So, I mean, this is, I'm sure it's becoming better and better as we speak, but this was the most shocking, in terms of green networking, it was one of the most shocking results that was published a few years back. And it is true that more often than not, people are, again, looking to obtain the 1% extra accuracy, but at what cost? And it's about finding that balance between them. So this is one of the projects that we're looking at, and we're moving away from artificial intelligence, you know, the fancy like reinforcement learning or what have you, and we're going back to the basics of heuristics. And actually the results are quite impressive. Because, again, for energy efficiency, we're talking about the downlink energy efficiency, so the downlink transmit power, you don't want to change that every second, not every minute.
Yeah.
So what is the time scale that you have in mind, and how long would it take you to reach the optimum solution for this new traffic scenario? And with that tool, which is a digital twin designed with complexity in mind for both the machine learning algorithms, the computation, and the simulation of the ORAN, it's really giving us very interesting results. So that's
interesting, Mona. Very nice to hear. Antonino, you want to add something?
Yeah, I mean, at the moment I'm working on a project funded by Innovate UK, is related to digital twin, but not on the optimization, but another topic that we didn't talk so far is about the security of the network.
Yeah.
Because we're gonna have open software, open interfaces. This will gonna be cost reduction, but at the same time we're gonna be more space for attackers inside the network, so they can have access to data, they can have access to the software, and they can compromise, they can do data poisoning whatsoever to compromise the network. So how use the digital twin to combat this? So basically you will gonna replicate your network, the Open RAN network in this case,
right,
and in a digital twin, and on top of this you will gonna use an abusive adversarial agent, which will gonna work like a kind of continuous penetration testing on the network in order to find the possible vulnerabilities and help the mobile network operators to avoid this vulnerability in the future. So we're gonna be this abusive adversarial agent that will gonna perform a kind of attacks in the virtual replica of the network in order to find weak points and, let's say, backdoors or possible, just simulate all the attack in the network itself, and those were gonna be.
That's very interesting.
Yeah, those were gonna provide because so far what they have done, mobile network operators, is just doing mobile penetration testing. So penetration testing require planning and sometimes not put down, but part of the network are gonna be not available. With the digital twin, you are gonna guarantee seamless, let's say, testing of your network for the mobile network of operators without interrupting the real activities in the network itself.
Yeah, very important, Antonino. So I remember this actually, Mona also has applications in ISAC, in sensing and comms together. Like security, privacy is really the biggest concern. So whether you combine with digital twin or you run it on your ORAN or not, but ISAC has the biggest really issue of security and privacy. So they have also included this, let's say, in to work around this in pre-standards and standards, because they want to like look for some solutions, because if you want to deal with sensing, for example, so let's say your car is going and it cannot be actually sensing around everything, right? There can be some sort of private networks around, and there can be some sort of sensitive information too, depending on the area that you're going through, for example. So security and privacy is really like are one of the biggest sort of like major concerns, like in besides all these increasing efficiency, increasing the performance, working on KPIs and so on. Security privacy is really, really important aspect. I mean, in terms of digital twin or even for other technologies. I mean, ISAC or non-trusted networks or even other technologies.
And I think with Open RAN, it becomes more exposed.
Yeah, exactly. That's what I was saying as well.
You don't have proprietary interfaces.
Yeah.
And then you have more than one weak link.
So should we stick to just RAN, or should we actually go for ORAN and basically try to deal with these problems?
We need to reduce the cost, as Mona said, so we need to go for RAN and find possibilities to protect the network, of course. There are in place some possible solution like homomorphic encryption, for example, or instead of transmitting the real data, the entire data, you can use federated learning, which we're gonna hide, so we're gonna help the model itself. So, but it's better to continue with the DO-RAN because this is the next direction. So we're gonna give more competitivity in the market and give the possibility to realize more performant policies for the network itself. Because for example, in the context of RAN, instead of directly deploying your X app or R apps, depends if it is the near real time or the no real time, you can before testing in your digital twin and say, okay, this will gonna fulfill my requirements. Okay, I can deploy. Then you can test different hubs from different vendors, and then you can decide the best of breed that you can deploy in your network itself.
So it does help us in these senses. That's great. That's great. So anything else that you guys would like to add before we end our podcast, Mona, Antonino, that you would like to talk about?
I mean, I would like to say, even if there are challenges, it doesn't mean that it's the end of the road. It's actually the beginning of the road. And it's an exciting journey. To have 6G and beyond, we need these advanced technologies. We can't have 6G with what we have today. We need to push digital twin to the next level. We need to push ORAN to the next level. And it's good to be aware of all the risks that we see. I mean, security as a privacy is a big problem for sure. But it doesn't mean that we stop there. We find a solution for it. And we keep pushing.
So that's a go-get-it approach. That's good.
Absolutely. Absolutely.
That's nice. Would you like to add something?
No, I completely agree with Mona. We have to work with the attitude of we were going to find a way or we're going to make it one. So
perfect. Great. So with this, I think we can conclude our podcast. Thank you so much for being here, guys. And it was nice to chat with you. And hopefully, maybe in next few years or maybe next year, perhaps we again meet and discuss about the sort of developments that have been happening and see what we discussed today with the ambitions. Have they been really approached or not? Or we are still missing on some things. So it'll be great to chat again. But thank you so much for coming today, and hope to see you guys next time soon.
Thank you very much.
Thanks for having us.
Take care. Bye-bye.
Great chat. Cheers.